Morning guys, on Exit Slip 710, our job is to be able to use formulas or graphs to make some conclusions and to see some patterns and be able to answer some questions here. So in this case we've got a graph. On my x-axis here is the time in hours, and then this is the distance that this train travels in miles in those hours. All right, so we're supposed to write an equation, and these questions down here are kind of small, so I rewrote them up here to make it a little easier. So make sure you get your answers written in as we go through them here. So we need to write an equation that you could use to find the distance, y. So remember the y-axis is right here. I want to be able to find the distance that a train travels in x hours. Okay, so x stands for the hours that they're traveling. Right, so I'm going to study this graph and see if I can come up with an equation that represents it. So I see right here, if they go 1 hour, the train goes 40 miles. Okay, and 2 hours looks like 80. 3 hours is 120. Okay, so I'm seeing that every hour it goes up 80. And I can easily see I go over 1 hour, up 80. Over 1 hour, or excuse me, up 40. Then over 1 hour, up 40 more. Over 1 hour, up 40 more. And that pattern continues. It's a constant rate. So I can know that every hour, all I have to do is take it times 40. So my equation, it's 40 times x. Remember, x represents the hours, this x-axis. Okay, and if I take every hour, just take it times 40, because they go 40 every hour, I can say that equals y. And I know y is, again, the distance that they're traveling right here is what y represents on that y-axis. Okay, so here's an equation written that represents this situation. 40 times every hour. They go 40 miles every hour will equal y. And we know, again, the y stands for the distance that the train travels. All right, so the next part is to use the graph or the equation to calculate how long it will take the train to travel 60 miles. Okay, so I'm going to use the graph first here. 60 miles, here's 40, so halfway, looks like it's 50, 60, 70, 80. They're going by tens there. So if I go right down to here and follow the graph over and up, I see right there at 60 miles, we're halfway between 1 and 2. So that would be 1.5 hours. I could do it that way, or 1.5 hours to go 60 miles, which makes sense because a full hour is 40. So if I go a half, it would be 20. So 40 plus the 20 more would be 60. I can also plug it into this equation up here. And if I have 40 times x equals 60, because we know 60 is the distance that they wanted us to travel, 60 miles. So I could do this and figure it out to get x by itself to figure the hours. I know to undo it, I divide by 40 there, so I must divide by 40 here. And that'll leave me with x equals, and if I take 60 divided by 40, that would get me 1.5 if you get it reduced. So x could equal 1.5 or 1 5/10, depending on how you wrote it. With a fraction or a decimal, again, it's 1 5/10 either way. So you can plug it into the formula and actually figure it out that way by plugging in the 60 as the distance, so plug it in for y, okay, and then solve for x because we want to know the hours, okay? But the graph is pretty easy to see it here too. So again, use whatever you would like to try to figure out those questions, but you can use the equation or the graph to be able to tell some of these things.